is Vodcast 8B. In this Vodcast, we're going to talk about limiting and excess reactants and do 2 example problems. Here are the definitions for limiting reactant. The reactant in a chemical equation that limits the amount of product that can be formed. This is going to be the one that's running out first. When this reactant runs out, the reaction has to stop because you cannot produce any more product after one of your reactant runs out. The excess reactant is just like it sounds. It has excess. There's extra. It's the reactant in the chemical equation that has extra that remains after the reaction stops because the other reactant, the limiting one, runs out and there's nothing left for it to react with. So what does this limiting and excess reactant look like? Here's a picture for an example for you. If I'm building cars, I need 1 body to 4 tires. So my ratio is 1 to 4. If I have 8 car bodies, my ratio is 1 to 4. 8 times 4 is, I need 32 tires. If I have 48 tires, for 48 tires, my ratio is now 4 to 1. 48 divided by 4, I could theoretically make 12 cars. But since I'm only given 8 car bodies, who's going to run out first? Car bodies is going to run out first. Why? Because the amount that I need is greater than what I have. In order to use all my 48 tires, I would need 12, but I only have 8. I don't have enough. It's going to run out. What is my excess reactant? Who's left over? Obviously, it's got to be the other one, tires. Why? Because if I used all my 8 car bodies, I only need 32 tires. When I have more than I need, thinking money if I'm going shopping, if I have more money than I need to buy what I'm looking to buy, I have excess money. I have leftover money. How much? What will be left over? If I have 48 tires, but I only need 32, excess equals have minus need, or 48 minus 32, I have an extra 16 tires. How does this work in chemistry terms, in our FLM? 2 sample problems for you. I would pause the video now because you're going to be asked to write the reaction first. So A, write the balanced reaction, and then come back and pick up B after you've had the reaction balanced. Writing a balanced reaction. Zinc and sulfur, all by themselves, that's easy, form zinc 2 sulfide. This is a 2 plus. Sulfur, sulfide is an S2 minus. This one's going to be nice and easy for us because my ratio is going to be 1 to 1 to 1. So, here's the little twist when we add in a limiting reactant. Now, I'm going to give you 50 grams of zinc and 50 grams of sulfur. So before we do any calculations, we have to figure out who's the limiting reactant, who is going to run out first. In order to do this, you can start with either one. It doesn't matter, 50 grams of zinc or 50 grams of sulfur. Either reactant that's given is where you can start. That's how much you have. You have to convert your have into a need for the other one. So, just because it's written first, I'm going to start with 50 grams of zinc. I want to convert grams of zinc, which is what I have, to how much do I need in grams of sulfur. If I have grams of zinc up top, I need to know the molar mass of zinc on the bottom. Looking at the periodic table, 65.39 grams of zinc gives me 1 mole of zinc. Again, my conversions are nice and easy because this is a 1-to-1 ratio. Moles of zinc cancel, but I want it to be in grams of sulfur. So 1 mole of sulfur is 32.07 grams. I started with what I have, 50 grams of zinc. I'm going to calculate how much sulfur I need. When you punch this in your calculator, it comes out to be 24.5 grams of sulfur. I need 24. How much did I have? Make sure you're comparing sulfur to sulfur. If both numbers are not 50, in this case it's nice and easy. If I have 50 grams, but I only need 24, I have more than I need. Sulfur is my excess. If sulfur is my excess, zinc has to be my limiting. Write down your questions on that. Pause the video. I'm going to go into Part C and D. Part C. How many grams of product, zinc sulfide, how many grams of product will be formed? Now, where do I start? I was given 50 grams of zinc and 50 grams of sulfur. If you remember back from the beginning, I can only produce as much product until my limiting runs out. So that's why we had to figure out who was our limiting reactant, and we figured out it was zinc. So now I have to know that I'm starting with what I was given, what I have, 50 grams of zinc. This one is important in who you start with. You have to start with your limiting reactant whenever you convert to your product. 50 grams of zinc. This is going to look very similar to the last one. I need my molar mass of zinc, which was 65.39 grams in 1 mole. Grams cancel. I'm converting, but it's again very nice because my ratio is 1-to-1. 1 mole of zinc is 1 mole of zinc sulfide. And then in order to get to grams, because it says how many grams of product will be formed, I need to look up the molar mass of ZnS, which is 97.46 grams. 50 times 97.46 divided by 65.39 on your calculator, I should get 74.5 grams of product produced. Again, always starting with your limiting reactant to calculate product. Part D, how many grams of excess reactant will remain after the reaction is over? How much excess did I have? Remember the tires? We just subtracted. Excess means I have more than I need. Now, if you've calculated the very first problem, Part D, the other way, you may need to do one additional FLM calculation here to figure out how much you need. But if my excess equals have minus need, and this was for sulfur, I had 50 grams. Going back to Part B, I only needed 24.5, so 50 minus what did I need? 24.5 gives me an excess of 25.5 grams of sulfur. So again, if I was in industry, this is where I'd use my stoichiometry. I would never start this reaction with 50 grams of sulfur because I wasted 25.5 grams more than I actually used. Second example. Pause here, write the reaction, come back, check your balanced reaction, and then we'll do some calculations. I'm going to write the balanced reaction for hydrochloric acid, HCl, reacts with iron. That says 3 plus, oxide is a 2 minus, Fe2O3, to produce iron 3 chloride, FeCl3, and water. Balancing this, I have 3 oxygens on this side. I need a 3 over here. That gives me 6 hydrogens. I'd have to put a 6 in front of my hydrogens. That gives me 6 chlorine. A 2 here. This would just stay a 1. So my ratio is 6 to 1 to 2 to 3. Now, if you're given 150 grams of hydrochloric acid as one of my reactants, and 200 grams of iron 3 oxide, who's going to run out first? Well, who do I start with? Does it even matter? No. You can start with either one. Again, because it's written first, I'm just going to start with this one. 150 grams of hydrochloric acid. This is my have. I have to convert from what I have to how much I need. Some point in time I'm going to use a 6 to 1 ratio, but since I'm given in grams, I have to go look up some molar masses. So the molar mass of hydrochloric acid is 36.46 grams in 1 mole. Thinking of my snowman, I just converted grams to moles. Now I need to mole ratio to a different substance. 6 hydrochloric acid has to go on the bottom because I have to cancel out moles of hydrochloric acid to 1 mole of Fe2O3, but I didn't want to get to moles, I wanted to get to grams, so I need another molar mass. 1 mole of Fe2O3 on the periodic table calculates out at 159.7 grams. So if I take my 150 grams of hydrochloric, multiply it by 159.7 Fe2O3s, divide by 36.46, divide by 6, my final answer is 109.5 grams of Fe2O3. This is how much I need. Again, comparing the proper things is key here. Grams of iron oxide, I have 200. I only need 109.5. So again, this one turns out to be my excess. If Fe2O3 is my excess, then HCl must automatically be my limiting reactant. Part C, how many grams of water will be formed? Using the same equation, 6 hydrochloric acid plus Fe2O3 gives me FeCl3, that's 2 of these. And how many waters? 3 waters. How many grams of water will be formed? Here's where I have to be careful. Who do I start with? I was given 2 amounts at the beginning. You have to start with what you have of the limiting reactant whenever you calculate any product. So going back to part B, we said hydrochloric acid was my limiting, and I'm given 150 grams. So I have to start with 150 grams of hydrochloric acid. I want to get from hydrochloric acid to water. My mole ratio is going to be 6 to 3, but first I'm in grams, so I need that molar mass of HCl again, which was 36.46 grams in 1 mole. Now I can do my mole ratio. The 6 has to go on the bottom, and the 3 goes on the top. Why? Moles of HCl cancel with HCl, but it wants to know how many grams of water will be formed. So looking on the periodic table, 1 mole of water is 18.02 grams. 150 times 3 times 18.02 divided by 36.46 divided by 6, you should get 37.07 grams of water produced. I could have calculated how many grams of this product we formed as well. What would be different? Well, the mole ratio would be 6 to 2, and this would have a different molar mass. But same concept. Part D. How many grams of the excess reactant will remain after the reaction is over? Excess reactant was Fe2O3. My equation, if you want an equation for excess, means I have more than I need. Excess equals have minus need. Going back to part B, how much did I have? I had 200 grams. How much did I need? Only 109.5 grams. So, how much did I have? 200.0 grams. How much did I need? Minus 109.5 grams. Do that subtraction in your calculator. That would give us 90.5 grams of excess Fe2O3. Again, I wasted 90.5 grams of Fe2O3, which you know may be very expensive, so that's cutting into my profit. So I need to readjust my ratios a little bit, or how much I start with. Again, write down all the questions you have. We're going to do this again in video C with adding percent yield.